So today we're going to talk about lesson 2-6, equivalent expressions with technology. If you remember yesterday, we put expressions on our calculator. We looked at our table to see if they were, equivalent or not. If we graphed them, if they lied on top of each other, they were equivalent. If you looked at your table and the y's matched up, the values that you got out matched up, then we determined that they were equivalent and so forth. Now we're going to look at formulas in geometry, how we can rewrite things that mean the same thing. Okay? A lot of people have a hard time with this. Please take your time, watch this video, and you'll have a better understanding. Okay? Please take notes. Equivalent formulas in geometry. In geometry, it's not unusual to see different area formulas for the same type of figure. If the area is found using different formulas, will the results be the same? Where do different formulas come from? We've seen where we've had different expressions that are the same thing. That's where this stuff comes from. Just because one person does it one way and finds the area does not mean that just because someone did it a different way, you can't find the area as well. Excuse me. Example 1 says, the picture below shows the area of a deck surrounding a rectangular swimming pool. The length of the entire region, pool and deck, is L. Here's my length of the pool. And the width of the entire region is W. Here's my width. Notice I have 2 L's and I have 2 W's. Okay. The distance across the deck is X. So this little distance right here is X. That's our unknown. We have no idea what that is. A says, find a formula for the area of the deck by splitting up the deck into 4 rectangles. Okay. First of all, we got to know what area is. Area equals length times width, correct? Length times width. So here's our length, here's our width. It says break this up into 4 rectangles. Well, let's do that. If I draw a line here and here, there's 1 rectangle. If I draw a line here and here, just like I did above, I now have 1, 2, 3, 4 rectangles. Okay? 4 rectangles. So, what I want to do is find a formula for the area of the deck, which means I do not want to include this area right here, my water, correct? So, how can you go about this? Okay, well, I could take the area of the whole thing and subtract area of the water. Does that make sense? Okay. If I find the area of this whole thing, okay, and I subtract the area of the water, would that give me the area of what I need? Yes. That's going to give me everything else, correct? So, this whole thing is W, this whole thing is L. So the area of the whole thing is length times width. Minus area of the water. Well, let's find out this distance right here. Here to here. Okay? Here to here. Well, if the whole distance is L, if this whole distance is L, that means I got to take L, and then I got to subtract one distance X and another distance X. So I got to subtract X, and subtract x. If I combine like terms, that is L minus 2x. Everybody with me? Okay, good. So that is my length. So length is L minus 2x. My width is, here's my width, correct? My width is W, and that is the whole thing, correct? Because W is this whole long side right here. So I don't have to subtract any x's off that. So my whole length is W. So if I wanted to subtract this or simplify this out, I need to distribute this. So I get LW. And then what happens is I got to subtract everything that I do in here. So L times W, I'm doing the distributive property, L times W is LW. And a negative 2x times W is a negative 2xW. So if I distribute my negative sign through here, that means I get LW minus LW. And a negative times a negative is a positive 2xW. Well, you're saying, well, Mr. Johnson, combining like terms, LW minus LW is 0. So all you are left with is 2xW, and that is the area of this region throughout here. Okay? Split up the deck in another way to find its area. Okay? So, I'm going to make my 4 rectangles this way. Dun, dun. Dun, dun. Got my 4 rectangles. So, once again, I'm going to do the same thing. Area of the hole minus area of the water. Okay? Area of the hole is length times width. Area of the water. Okay? Here, my whole thing is L. Okay? So I get L. Times the width. What's my width? Well, my width is W, and what I have to subtract is an X and another X. 1X here, 1X here. Correct? So it's W minus 2X. Okay? So I put W minus 2x in here. And if I distribute this out, LW minus a negative L times W is a negative LW. A negative L times a negative 2x is a positive 2xL. Okay? Once again, if you notice, my LWs are divided out. And the area of what I'm trying to find is going to be 2xL. So what happens is, even though we went about it a different way, okay, where I drew my rectangles at is going to determine a different expression but we're going to end up with the same thing once it's all said and done. Okay? Next step is we're going to find three expressions that are equivalent to 2a squared plus 4b. In each case, use a CAS calculator to verify the equivalence. We're not going to do that. Okay? We're just going to use our math. Okay? Step 1. How you can find three expressions or one expression to show that it's equivalent is you can look to factor something out. So when I factor something out, what can happen is I actually have the same thing, it just looks different. That's what equivalence is. You have the same thing, it just looks different. All right? There's a whole bunch of different ways you can make money. Okay? 10 cents, you have a dime, 2 nickels. Or you could have 10 pennies. Or you could have a nickel and 5 pennies. All those represent 10 cents. Same thing here. We want to get out 2a squared plus 4b, but we just want to write this a different way. So what could we factor out of this? Well, what do both of these have in common? If you look here, they have a 2 in common. 2 goes into 2, 2 goes into 4. So I'm looking for an expression where I take out a 2, so I'm going to say 2 times the quantity. If I take a 2 out of here, 2a squared, and I divide by 2, I'm left with just a squared. 4b, if I take out a 2, I'm left with 2b, and the sign in the middle is plus. So this is another expression that represents 2a squared plus 4b. It's just written in a different way. This might be the 10 pennies that represent 10 cents. Okay? It still says the same thing. It's just written a different way. Another way you can find an expression equivalent to 2a squared plus 4b is you can use the identity property of multiplication. Okay? Identity property of multiplication means you take something and divide it by the same thing and just multiply it together. So in essence here, they took 2y divided by 2y and they're going to multiply it to something. Well, when you take 2y divided by 2y, actually what you're doing is just multiplying by 1. If you take 1 times something, don't you get the same thing? Yes. So in essence here, we're going to do the same thing. What I'm going to do is I'm going to take 2a squared plus 4b, and what I'm going to do is I'm going to multiply that. I'm going to put that over 1. I'm going to multiply that by, let's say 2a. I just picked something random. I just use letters that they were already using because it makes it easier sometimes. So, remember, I'm just writing another expression that means the same thing. Well, the denominator's easy. 1 times 2a is 2a. Now what I have to do is I have to distribute this 2a across this whole thing. 2a times 2a squared. Well, 2 times 2 is 4. A squared times a gives me a to the third. You add exponents. 2 plus 1 is 3. Then I got to take 2a plus 4b. Okay? 2 times 4 is 8. A times b is ab. So this is my new expression that represents 2a squared plus 4b. I can check myself simply by either graphing it or by doing my math right here. If you remember when we divide, I have to divide to both things. So it's 4a cubed divided by 2a plus 8ab divided by 2a. All I'm doing is checking myself. This is checking. Well, 4 divided by 2 leaves me with 2. I have 3 A's. I have 1 A down here, so this A is going to take care of one of these A's, so I'm left with 2. Leaves me with 2A squared. Is that what I started with? Sure is. 8 divided by 2 is 4. This A takes care of this A, leaves me with 4B. Is that what I started with? Yes, it checks out. Very simple. The last step that you can use to have the identity, to show it the equivalence, okay, is using the identity property of addition. All this says is that you add 3x to one side and then subtract it again, okay? If you do something and then undo it, do you have the same thing? Yes. If I start with $3, I work for an hour, make $10, that gives me $13, but then I get a bill for $10, brings me back down to $3. Did I end up in the same spot? Sure. So for an example, okay, start with my equation, 2a squared plus 4b. So what I'm going to do is here, I'm going to add 5b. And on this side, I'm going to subtract 5b. But I'm not going to totally combine everything together. I'm going to leave some things the same. So 5b plus 2a squared, and I'm just going to combine these two because these are like terms. 4b minus 5b is a negative b, right? This is another expression that says the same thing as 2a squared plus 4b. So is this expression. This is the same thing. I just kind of shrunk it down a little bit, okay, per se. This says the same thing as this. How do we know that? Well, we know that 5b minus b is 4b, right? And so I'm just checking my answer. 5b minus b is 4b, right? Did I get the same thing? Yes. I know it's strange, but what all we are doing is manipulating things so they say the same thing, just a different way. That's all I have for you today. Please enjoy. We'll see you tomorrow.